2 circles. So now you can visually examine these sites. So you see these ones are outside the area of interest. It's not a concern to me. Okay. Now, in fact, if you want the tool to isolate stations up to 7 kilometers, you can click on the station here. Click on the radar, I mean, and then in the radar under the site, put the radius, put the extended radius. Where is it? The extended radius here. Put it to 7 kilometers. 7 step. So 7 kilometers. The advantage of the 7 kilometers now, if I click on that radar, I can tell the tool, please select for me the stations, isolate the stations, 5G stations here we're talking about, within the extended radius, which is 7 kilometers. So look what happens now. So all the sites that are outside are deactivated, okay, including the radar itself. So you might need to reactivate the radar. Activate, here you go. So I could delete the rest of the sites here, Control R. So Control R will take care of them, and then it will just deactivate them. So now I have the 5G sites that can be problematic to the radar, and I've deleted everything else. Now the next thing is I need to do some sanity checks. So sanity checks, for example, I mean, usually I'm looking at what? Looking at if the importation is done correctly, if the frequencies are correct, if the power is correct, if the antenna height is correct, if is the azimuth is correct, bandwidth, transmission gain, and so on. So it's just to do some sanity checks. And you check a couple of sites to make sure you're happy with them, to make sure the antenna is making sense to you, and so on. So this is different things, general things. Now, one thing you need to know with the propagation model ITU 450, which is used for terrestrial coordination process, you need to make sure that the antenna heights of these sites are actually exceeding the clutter height. For example, I'm usually worried if the site is sinking under the building. That happens if the building height is above what you expect, or if the antenna height is below what is expected. Okay. Sometimes the source is not very clean, so you need to be careful. Here you can switch to the building layers. So you see this is the building layer. So you can read here the building height. You can see it here under the clutter here. So you can move and then you can read. So here I can tell that the building height is, for example, 7 meters, okay? And I can check what's the site height. The site height is 30 meters, so definitely this is okay. So you can't do this manually, of course. So there's a function in the tool to tell you which sites, which antennas are sinking under the building layer. Now you could do this very quickly in the software. You go to Object, and then you go Activate, and then you go to Isolate by Query, okay? Isolate by Query, and then you say, all right, I want to isolate the indoor and in clutter. So indoor and in clutter means if the antenna height is inferior to the clutter height or building height. So you do this, now you see the all deactivated, which is good news. If one of them came active, then it means there is a discrepancy between the two. All right. So maybe we could take an example here, and then I can make something wrong, and then see how we can fix it. So let's look at one of the sites. Let's look at this site, for example, here. This is in the building area, so this building height is 5. Okay. Let's say somebody accidentally gave us here 4 meters height. Okay, 4 meters height. So you need to say if the software can pick up that mistake. So you go Object, and then you go to Activate, Isolate by Query, and then here we go, hit OK. Here we go, picked up right away. So the software noticed that this site antenna height is inferior or is less than the building height. So you need to go and fix it after that. Okay, you decided to boost it beyond the building height. Otherwise, the engine will underestimate the impact of that site. The predictions, the path loss will be more pessimistic. So I'm going to put it back to 30. Okay. So yeah, so this is how it works. Now, if you make any changes here, you need to go back to push back. You need to push back these stations to the database. Okay, so you need to push it back there, all of them. All right, done. So now I updated my model in the station database, because remember, whatever you do on the map is on the map. But if you want to make the changes in the station database, which is here, then you need to push it from the map to the database, and that's what I just did now. So to avoid, to make it simpler for me now, I'm going to just isolate that guy, isolate that radar, okay? I don't want to worry about the 5G sites on the map because I already have them in the database. So now let's continue with the setup. So we've got most of the job done now, but I need to look after the propagation modeling. And I need to configure the software a little bit, okay? So make sure that the software is able to read the clutter correctly. That's the first thing. This is the clutter I have in the area. So the red I expect is a building. You need to read here as I move. So this guy is a building, yes, correct. This guy is a park, yes, correct. This guy is a road, yes, correct. So this clutter has been manufactured, has been created from scratch to match ATDI's expectation for the clutter mapping. Otherwise, you need to change things around, okay? So it looks like we've got the good model in place here. So this is matching this, and the clutter settings, propagation modeling, propagation model. So a propagation model, you have to use the correct one for your case. Let me see what I have here in my project files. So I'm going to use ITU for 452, I believe, 452. We have 452-16 and we have -14. Okay, now I already have a setup for the model, for the ideal model you need for this kind of work. So I'm going to load it to make it easier, and then we talk about the settings again. So I'm going to import an existing PRM file. Here we go. So this is the model I'm going to use, ITU 452-16. It has Delta Bollington's diffraction engine, and for the subpath, we're using ducting, we're using multipath reflections, okay, 3D reflections on any terrain height above -1. So which means including the water surface, because usually water surface is 0 meters. And you could decrease that number if you want to be on the safe side. So reflections is calculated, and then this is the definition of the mapping. Not this one. Let me click on this again. Here you go. So this is you can define here the profile height estimate and then the nominal height estimate. Okay, so here you could use the advice from Ofcom. So if you find if we quickly find here the Ofcom aeronautical radar. Let me open it. I have a PDF file ready. Okay, so we're back here. So this is the file I was talking about. So what you could do here, you could just copy this information if you want to comply. Here you go. So you see here we have the sea level surface refractivity 325. So you need to go back to the software, make sure you're using 325. Okay. So sea level 325. And then the average rate refractivity 45. You've got 45 here. Okay, dry air pressure. The dry air pressure would be probably would be somewhere here. Air pressure. There we go. This is the vapor. This is the HPA. So HPA is 1013. So you can go. You see it's 1013. Nominal path center latitude. This is usually taken care of by the software because the software is using the map. Temperature 15. You can see the temperature is defined here 15. Okay, and then you could define all the parameters, including the nominal height. So if you're using a medium resolution clutter, then you need to copy this individual information. So you've got here the nominal distance, and then you've got here the nominal height. You just need to copy across the parameters from here to here. Okay, so that's it. Now we've got a model which is compliant with the requirements. So we've got the propagation model in place now.